name's Ethan Zelmer. I'm a fourth year computer engineering student, recently graduated at Toronto Metropolitan University. I took the software specialization in particular.
And my name's Jasper. Also took the software specialization, like Ethan.
I'm also a recently graduated fourth year computer engineering student at TMU, and I did the hardware specialization.
Same with Adam. I also did the hardware specialization.
And what's your name?
My name is Tree, by the way.
Our project was essentially to make a game that could be used in more clinical applications. So there's, when people think of games, normally they're thinking of like fun games, video games that we either play on our phones or consoles. But what we were really looking to make here was what's called a serious game. It's actually a small field of games that really focus on a goal other than just pure entertainment. We look towards implementing various biofeedback methods to introduce and experiment with different cognitive behavioral therapy techniques that people can use to manage stress, anxiety as various coping mechanisms.
So we wanted to find something that was relatively common and easy for people to relate to, and also something that would be universally stressful for everyone, right? Some people find, for example, playing a game or doing some certain tasks that really focus all your time, they can find that stressful. But we figured that a scary environment where the player is going to spend their time in a scary house is something that's easily related to and stressful.
Ours was a VR game. So then we have to use the VR headset. And on the VR headset, where was a sensor, that sensor was responsible for capturing all the bio-related signals. That includes PPG signals, or your heart rate, your pupil dilation. And then therefore, we could use that information to then determine how we can introduce our stalling and barring event to the user.
The game starts with the player entering the environment. It's a kind of weird house, and they are tasked with a few things to do, a couple chores.
Listen, I left a list of tasks for you. Just some simple stuff to keep the place in order. Can you handle that for me?
And as they explore the house, they are, first of all, being measured in terms of their biometrics. And the idea is that the house has these stalling events that happen. The stalling events are things that just raise the cognitive load, which is the summary of everything from the headset.
They stress the player out.
Stress the player out a little bit. And then we have 3 barring events that occur throughout the house.
So the purpose of these barring events are essentially, as the name suggests, bars the player from progressing further from the game.
And the barring events are an opportunity for the player to learn about different CBT skills and also have an opportunity to actually apply them.
So for example, the way we teach players CBT skills on this first stage, we teach them learning how to breathe properly or learning visual imagery to essentially help them calm better.
Let's try a technique called visualization. Close your eyes and picture a peaceful place. Imagine the details.
So the idea is that if you are doing well and you're applying the CBT skills, then the game will reward you in some way for doing that, and the game will adapt to that. And so it certainly is dynamic. The stalling events happen with certain probabilities that are related to the current cognitive load of the player playing the game in the moment.
So how our game measures stress is through using the Omnicept, which is the headset's custom cognitive load value. It takes the heart rate variability, your heart rate, as well as your eye dilation and your eye movement, and then it spits out a value that's supposed to be correlated to how focused and stressed out you are, and that's the cognitive load value.
As said by Ethan, it's a serious game, so we want to specifically target people who has anxiety disorder issues, or mainly just as a game that adds more meaning than just like an entertainment source.
How does our game distinguish itself from the games in the market? Is we were able to have the user see the cognitive load on while playing the game, and then also with all the advice that was given, all the CBT skills to cope with that, the user can then see it right after to then reflect how well did they use those skills to cope with all the barring events during the game.
Some of the gaps right now are that most of the projects that are like this mostly target kids and mostly target just one part of what we do. So we're looking at both learning and also giving the players an opportunity to practice these skills. So the idea is that you can replay this game many times as a clinical tool to measure your progress in applying these CBT skills.
Okay, so just to name a few, of course, time. That's a big issue for all of us.
Sure.
Aside from this Capstone Project, we also have our normal courses. We have to, especially when it hits the midterm season. That's when we have to okay, we gotta set this aside for a little bit and focus on a midterm.
Crunch time is real.
Yeah,
Yeah.
exactly. And
Yeah.
then at the end, there's an engineering day that's also like stresses us out a little bit because like we have to make sure that our game is playable and it's enjoyable as well.
I think overall, just like a technical challenge is
Yeah,
just like learning a new piece of software, right? There's always
that's
like bugs
true.
and things
Yeah.
like this that come with it. So that was, of course, challenging.
So the main platform that we use for basically the entire thing is Unity, which is a game engine that lets us create 2D and 3D games and VR games. So that was the main idea that we wanted to use here.
So we used a lot of object-oriented ideas in coding here because C# allows for some object-oriented programming. So specifically COE 318, which is software systems, is an introduction to Java. And another course that's also related for the same reason is the COE 528, which is object-oriented engine analysis and design. And I love to mention also that we did use some linear algebra.
Quite a lot,
First year,
actually.
from first
Quite a
year.
lot,
We worked
yeah.
with vectors. We took a dot product at some point.
Yeah. So, like I said, I'm definitely a software student at heart. And so I spent a lot of time working with Unity. And so I really found a lot of joy in coming up with our various stalling events. So things like, walking through the house and then suddenly a painting falls down behind you, or, you're walking through the room and then all of a sudden you see something like crawling on the ceiling, stuff like that. I really had a lot of fun being able to kind of take my software knowledge as well as a bit of creativity and bring that together.
So I initially worked on basically just getting the HP Omniset connected to the Unity Sparta stuff, getting all that connected, make sure sensors are reading properly. Apart from that, I also worked on the poster itself, which I had fun with. It's supposed to pretty much giving a brief summary of what our project is about.
There's a lot of the logic inside the game, so working on the phone call system and also the logic of how the barring events work and stalling events. Then I also worked on at the end of the game, you get a report card essentially, a report of how well you did. It shows the graph of the cognitive load over time.
So my contribution was getting the interactable system, with the user, with the world, having the hands to grab something. I also worked it on the how Jasper with the CL graph as well, having it display properly.
Yeah, so recently I actually got a job offer from AMD, so I'm going to be working as a silicon design engineer over at AMD. So I'm really looking forward to that.
For me, personally, since I have essentially a lot of free time after graduation, I'm trying to learn just expand my knowledge. Somehow, essentially, even though grad school is finished, I want to still keep learning and learn new stuff.
What's next is I'm doing my Master's of Science here at TMU. I'm going to be doing applied math.
I choose to go with the academia route, and I'm heading to my PhD at York University, and where I'll be researching on biosensors.
To me, I'd say a big one is just keep trying and don't give up. It is challenging. I had a hard time in my first semester, but really sticking with it, you will learn the skills that you need. You will learn not just the industry specific skills, but also how to study, how to work hard and build up your work ethic. And I think that that's one of the most invaluable things. Really push through, and you're going to do great.
I also think a very important thing is building a community.
Yeah,
Right? So that's very
absolutely.
important, right? So
Yeah.
it's so hard to do all of this alone. If you have a community of people who are in your class with you, studying with you, that's really what's important.
I mean, at the end of the day, still enjoy it. It's an experience, right? You only got 4 or 5 years of having your undergrad, right?
Yeah.
And then
You'll get through it.
you get through it. Yeah.
I firmly believe that if you go and you try your hardest to attend all of the sessions that are available to you, you'll be able to succeed.
Right.
Good luck, first years.